So, students, in this particular lecture, we'll be discussing about the second type of fusion welding process. So, in the previous lecture video, we discussed about the gas welding process. So, that gas, acetylene and oxygen is used to supply heat to join the materials, to melt and join the workpiece together. But here, we'll be using uh, electric current to provide heat for melting the workpiece together. So hence the name arc welding. So before getting into the arc welding process, I would like to discuss a few principles of current. So what happens in current are there are two main terminologies. One is voltage and another one is ampere current actually. So one is voltage and another one is called as current. So voltage is similar to your um, flow region. That is like water. You can take the flow of current also. So water flows from high point to a low point. You can never see water flowing from a low point to high point by itself, by means of itself. And until you use an external force, water cannot move from a low point to high point. Similarly, current also travels from a high point to a low point. So that is called as potential difference, which you would have studied in your basic electrical and electronics engineering. So potential difference is similar to your height difference. So when there is a difference in height, water flows. Similarly, when there is difference in pressure, air flows. So from a region of high potential to low potential, current will flow, electrons will flow. So that potential difference is actually called as voltage. So in your household, you will be using a voltage of 220 volt, which means that it is flowing in that particular potential difference. But if you see the large transmission lines, huge transmission lines around the countryside, there the voltage will be mentioned as 10,000 volt or 20,000 volt. So imagine that voltage with that of the 220 volt. That is like water flowing from tap to your bucket compared to water flowing from waterfalls. So waterfalls, water flows from very high height. The height may be around 200, 300 meters. So water flows from there. But in your household, water flows from a height of 2 to 3 meters. So depending upon the height from which water flows, the force of water will be higher. But that is voltage. If you take current, it is actually volume. It can be equated to the volume of water. Current is what it means is how much volume of water is flowing through your pipe. Higher volume is flowing, then your velocity will be higher. Lower volume is flowing, velocity will be lower. So that is the current and voltage, difference between current and voltage. So what happens in the arc welding process actually is that you are using a step-up transformer in your arc welding process. You see here, there will be a transformer used in the arc welding process, which is actually a step-up transformer. So what this step-up transformer does is it increases the current actually. The volume of flow of electrons is increased. So what happens? High current flows. Normally your current value, your household supply will be around 10 to 20 amperes. But using this step-up transformer, the current is increased to a value of 200 amperes. So what this increase in current does is it increases the volume of electrons flowing. Higher volume of electrons will be flowing through the welding region. So this is the arc welding process, as you can see the image here. This arc welding process can also be called by different names such as shielded metal arc welding process, arc welding process. So what this shielded metal arc welding process means is that there is a shield used to protect the welding region. So what is the purpose of this shield? I will discuss with you in the later lecture. So first we'll discuss the principle of this arc welding process. So what happens here is that uh, one minute. So as you can see here, there are two terminals used here. So one will be your, in terms of AC current, one will be your neutral, one will be your phase. So neutral end will be fixed with that of your workpiece, and the phase will be connected with your electrode or electrode holder. So here electrode is the piece which is used to transmit current to the arc welding equipment. So that electrode will be made of metal. Uh, Usually it will be the same material as that of the material which is being welded. So what happens is that current flows through the electrode. Similarly, the current will be flowing through the workpiece also. Phase will be joined to that of the electrode and neutral will be joined to that of the workpiece. So electrons will flow through the phase, which means that electrons will flow through the electrode and pass to the workpiece. If electrons pass to the workpiece, then the circuit is completed. Then there will be no reaction. It is similar to your electric motor. Sorry, electric equipment. Whatever electric equipment you are using. Similarly, if you say your fan, what happens there is there will be phase and neutral. So when you turn on the switch, what happens? Both are connected. So what happens? Electrons flow through your fan. When flow of electrons takes place in your fan, then it rotates. So the circuit is completed. The circuit is completed, then the electron flow is completed. But here what happens in the welding process is that the circuit will not be completed. So as you can see, there will be a gap here between the workpiece and the electrode. If there is a gap between the workpiece and the electrode, the electrons cannot flow from electrode to the workpiece. So because of this, what happens is that the electrons, as I said, they will be very high energy because of the step-up transformer. High energy electrons will be there. They will try to flow to the workpiece, but that process is being stopped because of the gap. So what happens because of that gap? The air will be heated by the high energy electrons and the air will get to a state called as plasma state. So in that plasma state, what happens? The air gets ionized, and then because of the ionized nature, now air can transmit the electrons. In the nascent stage, air is a sorry, I cannot remember the term. Air is a it's not a conductor, it's a non-conductor. But when it becomes ionized state, what happens is that it can conduct the electrons. So that conduction, when it happens, high temperature is generated, similar to your lightning. A localized lightning is created, which is called as electric arc. So that electric arc produces very high temperature, and that temperature is used to weld here. So just we'll stop with this. I will again explain the process of electric arc in the next video. I hope you understood this. Thank you, students.